What I want to do now, though, is look at an example of a random walk that is actually a walk. Imagine, if you can, a drunken farmer standing in the middle of a field. And every second, he takes one step in a random direction. Now, I want you to ponder the question, what is the expected distance from the origin in, say, 1,000 seconds? More generally, if the farmer takes many steps, is he likely to move ever further from the origin? Or is he more likely to wander back to the origin over and over again and end up not far from where he started? Let's write a simulation to find out. But before we do that, before we build any complicated computation, it's always a good idea to develop some intuition about the situation the program is intended to model. Let's start by sketching a simple model of the situation using Cartesian coordinates. Assume that the farmer is standing in a field where the grass has mysteriously been cut to resemble a piece of graph paper. Let's assume further, put the farmer right here in the middle, assume further that each step the farmer takes is of length 1 and is parallel to either the x or y axis. Clearly, this is an oversimplification, but it's a common approach to building simulation models. We start with something simple and then add complexity a little bit at a time. All right, after one step, the farmer will be either here, or here, or here, or here. So we see that after one step, the farmer is exactly 1 unit away from where he started. Let's look at the second step. Without loss of generality, we'll assume that he took this first step eastward. It will be symmetric if we went in a different direction. After the second step, he could be right back where he started, that is to say 0 units away, or he could be another step east, 2 units away, each of those a quarter of the time, and half the time he'll be there or there. How far away is that? Well, that's the square root of 2 units away. How do we know that? Well, let's look at our old friend, the Pythagorean theorem. We can look at it here, and we know that a squared is equal to a squared plus b squared is equal to c squared. Therefore, c is equal to the square root of a squared plus b squared. And if we go back here, we look at, say, that x, we see that a is 1 and b is 1, and therefore this distance here is going to be the square root of 2. All right, I could now look at a third step and keep drawing circles all over the place, but it's starting to get pretty complicated. And that suggests to me that it's time to stop drawing pictures, and you'll probably be relieved given my drawing ability, and instead start writing code.